Hi everybody, my name is Boyan from a company called StorPool, and I'm going to talk about latency and why that metric is extremely important for everybody who's building public or private cloud. Just a couple of words about me. I'm a guy that tried programming at the age of 10 and figured out I would not be a very good programmer. I've always been fascinated with business, so I guess I moved to the dark side, and I'm a business person rather than a technical person, although I have quite a bit of background in computers and stuff like that. StorPool is a company that does storage software, and we've been running this for 7 years now. And we are focusing on doing extremely fast, reliable, and efficient bulk storage software. It's integrated with CloudStack. If you want to learn more about it, you can check it out online. I won't waste your time with that at this point. So, we have any transaction processing system like web server, database, load balancing, or storage system has a curve that looks like that. And basically, when you start loading the system, we have one task running on one CPU core. It takes 1 millisecond to kind of do the job. Then you have a second one. It does about 1 millisecond, and it's all good till you kind of use the resources of the system. And at this point, most systems that are doing transaction processing are elastic. So they're almost, you're increasing the load of the system, and basically the system responds as fast as it can be. Most systems, though, that are production systems are not exactly elastic, so they have a slight slope due to caching and queuing and things like that. So the interesting part is what happens when you push a system beyond its abilities. So you have more tasks running on these cores, and at this point, any system kind of goes into the plateau mode, which is it gets congested. So you have two curves of any system that can process operations. You have the elastic mode, where you request more performance from the system, it delivers more performance. Then you have the saturation point, and then the system goes in congestion mode. It cannot process any more operations with the required level of performance or low latency in this case. So if you're designing a cloud, an interesting thing and practical thing is to know, how do I get the best performance? Well, you get the best performance when you get a system that's extremely capable, and you use it in the 1% of the capabilities of the system, and whatever job you ask from the system, it does it extremely fast. Well, the more practical thing that business people will tell you, what is the maximum point that I can load the system and have the lowest cost per delivered resource, which is a 99% utilization of the system, of the capacity it can deliver. And if you go above that, you basically get only pain. The system becomes irresponsive, you start to get extremely long response times, etc., etc. And we have a small demo that we'll show in a bit that kind of demonstrates that. So how high this curve is, or the plateau of the curve for the system, is kind of the system throughput. And when you see most vendors that show you any performance benchmarks, they're not at the very far right end of the curve. So they're showing you, 10 million IOPS or 1 million IOPS at latency that's so high that nobody is actually going to ever run the system at that level of latency. So this is not something new. It's kind of being, at least we have it in the bottom here, 1995. This one from Sun. It's kind of systems are elastic to a certain point, and here we're just like turn it around so it kind of looks quite a lot like the graph that we've shown. So this is nothing new, but it seems that a lot of people don't see it or have forgotten about that. Now, here for this example, we're using a couple of volumes, storage volumes in this case, that are both delivering 10,000 IOs per second. And we want to see the impact of performance or latency on the throughput of the system. In this case, we're looking at the block storage service of DigitalOcean, which they say, okay, if you got a volume that can do 10,000 IOs, you can use it for database or virtual machine disks. And we say, okay, let's examine that. So in many cases, cloud providers or your system admins will tell you, okay, these are some characteristics of the virtual machine or volume that you're going to get. And here you're missing the most important metric, which is how fast the system will respond to your request, which means how fast your application will be, how fast your pages will load, and everything that has to do, how many transactions your database can process. So here we've done a measurement across several public clouds to see what is the usual latency that you get from different cloud providers. So we have Dreamhost, DigitalOcean, OVH. And we've compared that to the leader in, or at least the named leader in cloud services, which is AWS in this case. And it has an order of magnitude lower latency than some of the guys. It comes at a price though, and this is in this case we've taken the exact same block devices that you can buy as an additional service from these vendors, like a shared block device. It's all SSD based, and in the Amazon example, it's provision IOs to reach to 10,000 IOs, and as you see, it's quite pricey. That's $300 per month, over $300. On the other hand, we've compared it to systems that our customers are using. We have 3 of them. A couple of them are production cloud that you can buy on the market. The third one is heavily loaded shared hosting cluster, which is not public, they're just using it internally. And it's called BCP, which stands for Best Common Practice. So the thing about it is it's using NVMe and HDDs in a specific combination to deliver very high performance and high quality for the end user. So we've done a little experiment where we've taken the same exact volumes that have 10,000 IOs peak performance. And in one case, we are getting a volume that has a latency of 2 milliseconds, and we simulate that. And then in the other case, we have a volume that can do about 10 times lower latency. In this case, about 0.3 milliseconds of latency. And we measure what would be the impact of the application and the workloads running on these volumes that would otherwise be sold as exactly the same volumes, 10,000 IOs and 10,000 IOs, 100 gig and 100 gig. But then the latency that was not announced, we want to show that this is maybe the most important metric for how much work you can get done. So in this case, we're taking the same exact virtual machines from all providers that we've listed, which is 4 gigs of RAM, 4 vCPU cores, trying to have as equal test as possible with all companies. And all of the volumes are running on SSD storage. All of them have 10,000 IOs limit. The tool that we are using for this test is PageBench, which is kind of the standard PostgreSQL test that you can find here on the link. This is their specification of if you want to run or test an application or database, this is how you do it, and we're basically using their parameters to run the test. And here I'll kind of play the video that my colleague recorded, because we've had this in the lab, but then we're also using this lab for a bunch of other stuff, so we had to wipe it out and kind of do development. So we kind of have a short 3-minute video that basically runs the test, has this volume with 2 milliseconds latency, and shows what happens when you start loading the system. And then we have the same thing with a volume that does 300 microsecond latency and shows how the system would behave. So there we go. We managed to get it. Can I switch between the controls on the? Oh, yeah, because a while ago we managed to kind of play it, and now it's. I guess it's just taking my voice.
Why? Try now.
Anyhow,
Did you press the mute button on the screen?
a couple of times.
I don't know.
Yeah, it's okay. I'll give a quick explanation then. Then we have a couple of VMs on each side of the screen. They're with the same parameters, so we have, in this case, 300 gig volume. On both sides, we have 4 gigs of RAM on each side. And we're going to run some performance tests. Here we have a small mess up, I guess. These are the parameters we're using. We're using FIO, which is a standard test for performance on Linux box devices. And it has, you can see the parameters like box size is 4K, random read write 50/50. And these are the devices that are attached to the virtual machines. And here my colleague messed up a bit, so he'll just clean that in a second and we'll get to the test. Okay. So let me see if I can move a bit. Okay. Okay, so we're running the test here, and this box device can do about 4,000 IOs, which is 5,000 reads, 5,000 writes, so 10,000 read writes in total. And we're looking at the latency here. Let's the average latency of about 5 milliseconds, I think, and this is the other one that does similar, like almost, sometimes it gets a bit more, but on average should be about 5,000 and 5,000. And here you can see the test when it's running. It does about 4 milliseconds of latency with a PG bench test. So I'll skip a bit forward. With duct tape. So here he's performing a test where he's loading the system and increasing the latency of this volume. So after some time you get the system clogged in that, So the latency of the application starts to pile up. We go above this near the curve that we mentioned, so the latency starts to go up and up and up. And here on the other side we'll show same performance. Now skip a bit forward, where the latency stays about in 5 to 10 milliseconds of latency on the application level on the Postgre PG bench test, but doesn't go too high. Let's see. I'll skip that. So, because we couldn't really hear all the things, we have a summary of the result as a backup, obviously. So we have the 4 CPU cores, the 4 gigs of RAM, 10,000 IOs, and we have a storage device that can do 2 milliseconds of latency. That would give 900 transactions per second on the database at about 8 milliseconds of latency. Now, if we ask this system to do 1200 transactions per second, because it's not fast enough, the latency is too high, it starts to pile up. It goes above the knee of the curve, and it becomes like saturated, and the latency just starts to pile up, and the users start to get applications that are not responsive. They start to get pages that are not opening, their application just goes dark. On the other hand, if you have a storage device that can do 0.3 milliseconds of latency or 300 microseconds, it can do about twice as many transactions per second at 5 millisecond latency. So it's already twice as many transactions per second at about half the latency. And then if we ask it to do more transactions per second of that same system, it doesn't collapse. So here we plotted, I'll just hold it. Here we have measurements of several different clouds. Again, the ones that we showed. Yeah, or I can just try to.
Is it switched on?
How is it? How is it now? Or is it? Yeah, okay. It's falling apart. But anyhow, we'll hack it together. Here we're showing the same. Do you guys hear me? Yeah. Should I use? Yeah, that's fine. Okay, cool. Here we have the companies that we've shown, and we're seeing the DigitalOcean here in kind of like yellowish. They say, okay, we can use this service for running databases, but then if you look at the latency, it's kind of not that good. If you look at Dreamhost, for example, or OVH, basically their service is practically useless for running any database or high demanding workload. It barely gets off the x-axis. And just, the level of saturation of this curve is very low. On the other hand, you can see AWS, and there are a couple of important things. One is it can go and process about 3,500 transactions per second. But the more important metric is how close to the y-axis this curve gets. So they can do quite a lot of latency. Basically, you can see way better than anybody else, at least about 4 times better. And as the load goes up, they can run a database. The other guys pretty much cannot. Now, here we plotted also the other 3 companies that we mentioned. Like one is Togglebox, which is a customer of ours and has this performance curve that goes above and beyond AWS. And the other one is the StorPool BCP that I mentioned is the best current practice that's running in NVMEs. And you can see that if you're running a service or if you're a mobile app developer and you go and you check out VM from DigitalOcean or Dreamhost or some of these guys, your mobile app is not going to perform at all. It's going to get stuck. If you're running AWS, it will be okay, but it's going to be extremely expensive, like $300 per month to run that volume. And then you have, by using very good technology, you can basically increase the application of the performance of all the applications. like this curve on the best current practice that we have, as I said, that's a production cluster. It goes to about 9,000, like 8.5, 9,000 IOs, and it's still under is about millisecond latency in this case. So there are many ways in which you can increase the performance of your applications, and most of the things people have already done, like caching the application and rewriting parts of it so it's lightweight and fast. But here we wanted to show that if you have extremely low latency storage system, or latency in any storage system that's low, you can basically tenfold the application performance without changing much, or increasing the application performance tenfold above what you've already done in caching the application and improving it otherwise. And that's kind of the message we wanted to get out is latency is maybe the most important metric of your cloud, because IOs and price are not the thing that matter that much for workloads that are that are latency bound, meaning transaction processing. And this is usually not announced from vendors that are showing you this or selling the services. So that's that. Do you have any questions?
Yeah, adding to what you just said, StorPool storage looks like it's got the main latency load and all the others. What's yours in concern to price on the ROI?
Let me see. We have, I think, okay, here we have. So here we have taken the price of the storage volume itself, not the VMs we said we were buying. We went and bought virtual machines from all of these providers. They're all clusters that are production clusters, so we cannot change the utilization or how many users are running on this service. So what we can control is getting the same amount of resources, in our case 4 gigs of RAM and 4 CPU cores, and running the same service. And what we can get is how much is the storage device itself, because we're measuring latency in this case of the storage bulk device. So here are kind of the metrics that we've seen. So some of the customers are selling it for less, some of the customers are selling it for more. So I think they're all making money, and it's a matter of when you ask about overall return, everybody has, I guess, a different return. They decide if they want to price more, price less, price on the compute, price on the storage side. But this is the ballpark. It's like $20, $50 for 100 gigabyte volume that they're charging on the market. And AWS is about 6 times more to 10 times more, depending on which provider you're looking at. The EAPS company from our customer is a managed service provider. So they're offering service that's on top of the standard VM. Togglebox is direct competitor, I guess, with DigitalOcean and OVH, and DrinkHost is selling just a regular VM, which is unmanaged.
So you're saying Togglebox and EAPS is your partners?
Yeah, correct.
But I still don't get what you do directly. What's your price directly? You just work with them too, that's it.
We basically help them to build the storage layer of their cloud. Let's say they have standard super microservers, they're layering KVM on top, running CloudStack on top, and we're providing the storage system like Ceph, but way faster and way lighter in terms of CPU and RAM utilization, and allowing them to get performance that's much higher than what's currently available on the market. So they would otherwise have to go and buy a NetApp or a SolidFire box, and we're basically providing a software that runs on the standard server, sometimes alongside applications, and helping them to have extremely good and fast service, so they're very competitive on the market. And when you're asking about ROI, how these kind of technical measures match the business case, well, if you have a system that's very low latency, that means very good quality of service for customers. That means that customers are not churning, they're not leaving to you to go to AWS because they get enough performance. that creates word of mouth, that creates customers that are happy and are staying with you, that helps you onboard new customers. And if you browse these guys, you can see the collateral that they come out with, like the EAPS, for example. They published an interesting paper of, this is what we can do, and if you go to Amazon, it's going to be extremely expensive. So, this is something that they leverage technology to achieve business goals and grow the overall business.
Question. So what interface are you exposing to CloudStack? Is iSCSI NFS? Or how are you
iSCSI. Or we have, with CloudStack, we have our own driver and we have integration with CloudStack. So basically it appears as a single VOG device for a virtual machine. Otherwise we have also, that's with our own driver and then integrations for a bunch of solutions. We've got OpenNebula, somebody mentioned, we've got integration with OpenNebula as well. We have one with CloudStack. For other stacks like bare metal servers or for VMware environments, we do iSCSI. Although we've developed our own iSCSI target, so we did high availability, and we also added scale out. So we were able to push these numbers that we're showing here. We can do similar numbers on iSCSI, not exactly the same as with our own driver and the CloudStack integration, for example, but we can easily do like 100,000 IOs per VM. So that's something that's not that easy to do.
A quick one, once again. Is that dependent on the region?
No, it's mostly when you mean is the performance dependent on the region or?
Yeah, yes.
No. Well, in a certain way, yes, because these are all production clusters and they are of different size. So we don't know, for example, how many servers Dreamhost has in this particular cluster. We just go on their website, purchase a VM with this set of parameters. So there is some deviation between how old it is the cluster in that particular moment, or what is the hardware underneath that kind of VM in the particular region. But basically, the big difference is what is the software and hardware stack that they're using. It's not so much region to region, it is what is the technology that they're using and how capable it is. So, as I said, with these two, like the purple one and the green one, this is SATA SSDs on Supermicro servers, this is NVMEs on Supermicro servers. So, they're just the newer generation of hardware, and obviously that pushes the boundary of what performance and latency you can get.
So it's like a software-defined storage array. You can bring your own hardware, and the latency is so great that you get better utilization in your compute layer because you've got less CPU wait cycles. So it's that low cost. You can build your own flash array, but you get to buy hardware from Supermicro, not from Dell or NetApp or something expensive.
Correct. Yeah. So I have, at least on the StorPool side, there are a couple of things. The first thing is you can use white box servers. You can use Dell, you can use Lenovo, you can use Supermicro. I think as Guido said, like in the cloud and hosting industry, like 90% of the guys are using Supermicro, but you see all kinds of stuff like Huawei and Inspur and HP and Dell, and I mean you name it, QCT, Intel servers, but you're free to use whatever you'd like. We have a hardware compatibility list though, so you can have predictable performance and reliability of the system, so we qualify some components. For example, I recall on one of the previous CloudStack meetups, Guido did a very good presentation of ways to break a software-defined storage system, and he was showing consumer-grade SSDs without power loss protection. They can get you in a lot of trouble. So I have a hardware compatibility list saying, well, you'd rather have data center-grade SSDs. And with some of our resellers, we can also deliver package solutions, so we eliminate the guesswork for people of what component should they buy. On the second layer that you asked, we are basically able to merge storage and compute in the same standard server. So on top of being like a SAN built out of standard servers and best-of-breed software, we can also run hyperconversion, kind of optimize additionally the business case of people that want to build clouds. Any other question?
So do you allow for snapshots via CloudStack? And is
Yeah. Like Venko is one of our technical guys, and he knows the system better than I do. Obviously, the integration part. So we basically with StorPool we've aimed at doing a system that's extremely fast, very scalable, but it's not at the expense of features. So we have quality of service features of limiting IOs and megabytes per second per volume. We have snapshots and calls. We have copy on write format, which helps a lot with performance and instantaneous snapshots. And some of this functionality is integrated through the CloudStack integration. Other parts we're working on integrating, and I think the quality of service, I'm not sure
Quality of service, I think, is not. So
it's not yet.
Snapshots are yes.
Snapshots are, quality of service, we're working on that.
Okay.
On migration, you mean migration
migration
from other storage backends to the StorPool solution? Well, basically, we are helping our customers. If you decide to use this technology, basically both tech teams are working together to do the migration. Sometimes you first migrate from Zen to KVM, and it's like from other stacks to CloudStack or whatever storage system you're using. But otherwise, we provide a storage bulk device, so it shouldn't be such a big deal to kind of copy data. But obviously, we help our customers with the migration.
Do you have replication between clusters? Like if we build 2 pods and you want to fail over zones, do you guys do all that behind the scenes too?
So the way it works, like most storage solutions, like I avoid the software-defined buzzword because we've started before that existed. Most storage software, if you look at a very high level, they are very similar. So have a set of clusters in a given data center. Usually you use synchronous replication. In many cases, in most cases, you're using 3 copies of data. Some use 2, but that's guaranteed to fail at some point. So we usually use 3 copies, and that's synchronous replication within the cluster. So we do self-healing. We can do it multi-rack. So if you have a whole rack fail in the data center, it can survive. And then we have another technology that does synchronization between 2 clusters. So we can have like a backup and disaster recovery side. And this backup and disaster recovery side, basically, how it works is you take snapshot of all the VMs or some of the VMs in the primary cluster. You do async backup to the secondary cluster, and that's efficient backup, meaning only the deltas that have changed over time are copied after the first sync, obviously. And then you can restore from the secondary cluster if something happens in the primary cluster. In some cases, we have customers that have exact replica of the same data centers, like primary hardware. In other cases, customers do high-performance primary side, and they have less powerful HDD-based system in the second side for kind of backup. Some guys want to kind of replicate both and be able to kind of shift workloads if disaster happens in the primary side.